going to talk about complex numbers today. What do complex numbers have?
Complexion.
Eyes. We have eyes in them.
Oh, we're talking about imaginary numbers.
Yeah, so remember an imaginary number, I squared equals -1, so that means I is just the square root of -1. A complex number is just anything of the form a plus bi. It's possible for either the a or b to equal 0. You don't have to have those, but we call it, the a is our real part, the real number. The b is our imaginary part, the imaginary number. This is the standard form. So real plus imaginary on any of these problems, I will say write your answer in the standard form. So that means I expect a plus bi, real plus imaginary, every time. So good. One thing that you may not have discussed last year, but we are going to classify numbers. So if it's a complex number, we can classify it. If I'm talking about a real number, that doesn't have an imaginary, so it's just a. Pure imaginary doesn't have a real part, so it's just the bi. If it has both, the a plus bi, we call that non-real complex. It has both portions. All right, so let's look at some. I want to identify each number as real, pure imaginary, or non-real complex. So use all that apply. All of these are complex numbers. Any number of form a plus bi is considered a complex number. But I want to know, what else are these?
The first one's pure imaginary.
Okay. So when I look at 13i, it doesn't have a real part, so that is pure imaginary. When I look at 5 plus I,
Non-real complex.
right, it has a real part, it has an imaginary part, so non-real complex. And pi.
I want to say real.
Yep, it doesn't have an I in it, it's just a real number.
Where are the towers today?
Is this one okay? All right, so let's talk about simplifying these. So when you have the square root of a negative, we can think about reducing radicals. We broke them apart and did the square root of each one. If you separate it into the negative, we know the square root of -1 is I. So radical 5i, I think Mrs. Keller usually had you write the I in front, so I radical 5. Both options are correct. Just make sure that if you do it the first way, the square root of 5 with the I after, the I is not under the square root. So just make sure that's obvious from your paper. But otherwise it does not matter which option you choose. So we will always write our answer without any negatives under our radicals. So we will pull out I's whenever possible. When we work with any of these, it's also very important to pull out the i's before doing other calculations? An example to kind of illustrate that, if I said the square root of negative 4 times the square root of, let's go with a nice one, negative 9. If you just multiply those, you get the square root of 36, which is 6. But that is not the right answer. Why? Yeah, the square root of negative 4 would be I square root of 4. Square root of negative 9 is I radical 9. When you multiply those, I times I is I squared. Radical 4 times radical 9 is radical 36. What does I squared equal? I squared 36 is 6, so the real answer is negative 6. If you don't pull out those i's first, you will be off at the end. So always take out the i's as the first step. Bless you. So far, so good? Alright, so if I asked you to give me, I'm going to put a few up here. Okay, I want you guys to do each of those. So what is the square root of negative 1?
I.
Alright, how do you break apart the square root of negative 8?
4 and 2.
Take the I.
Okay,
And
if they
the
got an I, square root of 4 is 2, so we write it.
I. Square root of 2.
Take out the
I. Oh.
So we get 3i radical 5. Do I have to put plus and minus in front of these radicals? No. When do I need a plus and minus?
whenever you put it out, like, square root in front of it.
Yes, if we put the square root in front of the problem. If it's already there, we don't need it. Alright, so far so good?
If we put this,
What?
If we're solving a problem and we add the square root,
Oh, that's right,
then we
that's
have to
right.
put it. Alright,
Whatever. They're gonna catch my point. Oh no, I don't know what you're doing, but I don't like it.
this isn't a FOIL situation, right?
we do not need to FOIL because
Okay.
we don't have multiple terms.
That's what I thought, I was just making sure. I didn't quite look before now.
So what do we do?
You take out the i's.
Take out the i's.
That is the
So-
only answer she's gonna give you.
Square root of negative 6 becomes I radical 6.
Oh my god.
Square root of negative 10 becomes I radical 10.
And then you multiply the
Mhm.
inside, the little thingies,
Mhm.
the, yeah,
Under the radical, 6
Yeah.
times 10 is
and
60.
then you make it I squared.
Okay. I squared is negative 1. Can you break down 60?
I haven't got that one.
With, yeah,
Do you have to 115?
thank you. I couldn't remember.
So square root of 4 is 2, so we get negative 2 radical 15.
That was less painful.
Not too bad?
Pretty good.
Alright, what if I gave you
Oh, fine.
this?
I remember this is so funky.
What are your thoughts?
You can't have a radical on the bottom, so you have to multiply by radical 24.
Okay. So we can't leave a radical on the bottom, so the suggestion was to multiply by radical 24. Let's try it.
Oh, try it.
Huh?
She said, let's try it, that means I'm wrong.
No, it's gonna work. Alright, so
50 I. Oh, and you got to
Oh my god, why would you do that?
alright, so now what do I have to do?
take the I.
Take out the I. What else?
And then you have to find
Split it
the
up with
denominator.
magic.
Okay, I need to find something that goes into that.
We could have just. I'm gonna say it's like 216 or something. Wait.
I think 24.
Oh.
Sorry, 24 squared. So 576 and 2. So square root of 576 is, so we get 24i radical 2 divided by 24
So wouldn't it just be
I radical 2.
There's gotta be a simpler way,
There's
right?
got to be a simpler way. How else could we have done it?
Could you simplify it before?
Okay, both of these are under the radical. So,
If there was a negative in the bottom, would you have to simplify before?
it actually won't matter. You'll get the same thing. I'll show you one to illustrate that. Since these are both under the radical, you could reduce them. We take an I out of the top. What is 48 divided by 24?
2. That makes me so mad. That makes me so mad.
Wait, what?
Abby, why did you suggest that?
Because
It worked. She wasn't wrong.
No, you weren't wrong though. It's just gonna do 5 minutes.
And
Abby.
Your way like took half my lifetime. It took 2
okay, well,
seconds.
you don't.
We got there.
You'll be fine.
She's just mad.
All right, so the other question was, what happens if
Negative.
we have negative on both the top and the bottom? Do you have to take out?
No. You just told me that.
So if I gave you this. So let's do it both ways. If you took out the I, so what happens to the i's? They cancel. 20 divided by 2 is 10, and it's still under the radical, and it doesn't reduce. If you don't take out the i's, what is negative 20 divided by negative 2? And we still get the
Did
solution.
you just say 2?
So it's really only when you're multiplying that you have to make sure you take
Okay.
out the i's before you multiply.
Okay, multiply, take out eyes, gotcha.
All good
Take out
points.
those eyes, but
Any questions there?
no.
Alright, so we can handle reducing radicals. Let's try some operations with radicals.
Oh, wait, I remember this.
It's just combining like terms.
Yeah. The I doesn't change anything. It's just like any other variable in terms of working the problem. You combine like terms.
I can check your head.
I do expect
His head- oh, actually, his
all
head was anyway.
answers to be written in A plus BI form. So if you put the I part first, I'll take off a half.
Oh.
So 3 plus negative 2 is 1.
What the I
Positive 5i plus 3i is 8i.
It's an easy line writing it down.
Alright.
Don't ask me, I'm gonna tell you the word you know.
So the next 1. What do we have to do?
You would have to distribute the negative.
And then we can do
So 6 plus negative 3 is 3. 4i minus 6i is negative 2i. So we get 3 minus 2i. Okay. Do we need another adding and subtracting example?
No.
And we could do it with more than 2. You just continue to add like terms. All right. Next up.
She went, no, don't do it.
Oh, you've done it.
I've done it.
You've done it.
So it starts out the
Yes,
same.
we're okay.
I'm asking you to multiply. Just think if there were x's in there, how would you multiply it? Foil. So that's still true. We're just going to foil here.
Could you like stop before you like 2 seconds? 2 seconds.
All right, so 5 times 2 is 10 plus 35i plus 6i plus 21i squared. Okay, so if we combine like terms, this gives me a 41i. What is I squared though? Negative 1. So this is 21 times negative 1.
So it's minus 21, so it's going to be negative 11 plus 41.
All right, so just make sure you do change out that I squared for a negative 1 when it appears. What if I gave you four plus 3i squared?
I know.
You're foiling, except for it's easier.
I know why.
Yeah, because you just got to do the first 2 and the last 2.
Mm,
Wait.
First square,
Wait,
second square, first times, last times 2.
that's right. Wrong one.
So, we have to go ahead and just write it twice in FOIL here. So we get 16 plus 12i plus 12i plus 9i squared. Okay, 12i plus 12i is 24i. 9i squared. So combine like terms. Have to put a plus bi, so make sure the real part is first. So 7 plus 24i. Questions there?
She's really dead set on
On what?
no more foiling.
It's just
So,
time.
it's easy, but time consuming and annoying. Of course you have to.
So, this one, I'm asking you to put it in standard form.
Now wait.
Standard form means A plus BI. So we have to somehow
Get rid of the I.
get rid of the I on the denominator.
Times it by I.
Now, we can't change the problem, so whatever you do on bottom, you have to do on top.
Right.
So we get 3i over I squared.
Divided by I.
Oh, that'll just take you back to where you started. What's I squared?
Negative 1.
So 3i divided by negative 1 is negative 3i. So that would be my standard. So how do I get the 5 minus I?
Divided by 5 plus.
Right. If you just multiply by 5 minus I, we already saw one where we squared. The I didn't disappear. It just got shifted into a different term. So we have to multiply by the conjugate here, which is the exact same thing, except you change the sign in the middle.
This is the one where you times the first two and got last.
On the top, we do have to FOIL, so we get 15 plus 3I plus 10I plus 2I squared. On the bottom, you get 25 plus 5I minus 5I minus I squared. Now, on the bottom, they're conjugates. So what happens every time is that the first and last terms are going to cancel each other when we multiply in the middle. So the positive 5I and negative 5I drop. So if you just want to multiply first and last on the bottom, you can. So I have 15 plus 13I. 2I squared would turn into, okay, on the bottom I have 25 minus I squared.
Which is plus.
So I get 13 plus 13I over 26.
Divide by 13.
Yes, we have to, since I said standard form, you have to go ahead and separate this fraction. So we have to think about each of those over the denominator. So 13 over 26 reduces to 1/2 plus, and 13I over 26 is 1/2 I, or I over 2. I want you guys to do a few. Those are yours. So I saw 2 different approaches on A. Most of you multiply by 9I. So you got 45I over 81I squared. So that's negative 81. And then when you reduce, 45 over 81 reduces to 5 over 9. So you get negative 5/9 I. Did you have to multiply the 9? No. You could have also just multiplied by I, because the 9I is all one term. If you did that, you would get 5I over 9I squared. 5I over negative 9, which is the same. So in that case, it doesn't matter. You just reduce later on if you did multiply by the 9. B, what do we have to multiply by? So for FOIL, we get 16 minus 12I and minus 12I is minus 24I plus 9I squared. On the bottom, they're conjugates, so just first and last. So 9I squared is negative 9. So 16 minus 9 is 7 minus 24I. Negative 9I squared is positive 9, so 16 plus 9 is 25. So break it apart for the standard form. So 7 over 25 minus 24 over 25I. Is that okay? I have 2 things left to discuss. Are we okay to go ahead and finish it, and then we can do a work day tomorrow? Or do you want me to stop and finish it tomorrow? Work day tomorrow, you guys can stick with me for a couple more examples?
Yep.
Okay. So we are leading into quadratics, and we are going to you probably recall the quadratic formula coming into play. So we'll see some expressions along these lines showing up. So I just want to make sure now we kind of review how to go about reducing those kinds of things and writing them in standard form. So what would I have to do with this one? Take I out. Okay, so how am I going to break apart 128?
Not 16 and 8.
4 and 32.
Yeah, but
I can go further.
both of those can be compressed.
Yeah, it can go further. So is there a bigger one? Bigger perfect square? 16 and 8.
It is also something. It works, but
It works, but let's think about that. What perfect square goes into 8?
4 and 2.
4. So what's 16 times 4?
Got
60.
So we can do 64 and 2.
I was getting that.
So square root of 64 is 8. I radical 2 over 4. Divide. So negative 8 over 4 is negative 2. 8i radical 2 divided by 4 is 2i radical 2.
That's a lot of twos.
That's a lot of 2's. You guys do B.
I didn't even get.
So you can break 200 up into... So square root of 100 is 10. We have to take out the I. So 10 divided by 5 is 2. 10i radical 2 divided by 5.
Once again,
2 plus 2i radical 2.
Yay, we're finished, right?
What?
no, one more.
One more thing.
Okay.
Now this one's.
She's really waiting for those keys to solve.
Oh, I'm sorry. I had already forgotten about them. I'm so sorry. Do you want me to say this one for tomorrow?
Math is better.
I got
Math
this.
is
Just do it and we'll rush.
Okay.
I try not to break my toe even further. I didn't actually break my toe.
Oh, how?
No, I didn't, guys.
Yeah, do you guys remember doing
Oh,
powers
wait,
of
is this
I?
like, yeah, I think
You
so.
split it, and it's -1 to whatever, and it sucked.
So,
But
we
this-
know that every time we get two i's, they turn into -1, right? So if I say I to the 12th, the question is, how many groups of 2
Sucks.
can we make?
6.
So we have I squared 6 times. Okay, but what is I squared?
-1.
So if I have -1, 6 times.
It's just 1.
It'll be positive, because if you multiply 6 negatives together, it becomes positive.
Wait, so if the negative.
If it's even, it's gonna be
Positive.
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 Negative, it's gonna be.
Yes.
Why did she teach
Give us
us?
the.
Huh?
I don't put it into calculus. Kelly, why did she just teach us?
I thought you teach Thomas
Make it
before.
Alright, so if I
Why did
said
you say that?
I to the 33rd power. So the question is, how many groups of 2 can we make?
16.
16. 2 times 16 is 32. I need 33
Then you just add
times I. So we have -1
Sorry.
to the 16 times I. So what's -1 to the 16th? 1. And 1 times I is I.
Just I.
So when you stragglers would be.
Okay.
So the stragglers would be.
Gotta be.
Yep.
How do you say that?
I'm going to do a couple more of these just to practice and kind of show you a few, all the different variations. So if I said like I to the, let's say
Just trying to map it out in
66
your brain.
power. So
3.
I squared to the 33. What is I squared? And -1 to the 33rd power.
Is
It's
negative.
-1.
Okay, last variation.
Then what is
Let's do
gonna
it.
be negative I?
Uh-huh. There's only 4 possible answers on these. So if I said I to the,
She's really negative.
169.
No, Abby, you're such a child.
let's see.
That sounds really overcoming.
Let's
I just said a number. It popped out of my head.
83rd power.
And I wasn't thinking about it.
83rd, that is?
Yep.
Oh.
So, how many groups of 2 can we make?
41.
And that counts for 82 of them, so there's 1 left. I squared is -1
Okay.
to the 41st times I. So -1 to the 41st is
Negative